Welcome to this video on exponents. Let's begin. First of all, I want to talk about how we can use multiplication to express this idea of exponents. So, for example, we have 5 times 5 times 5. So we're multiplying 5 by itself 3 times. Exponents are a more efficient way to express this idea. So we can rewrite 5 times 5 times 5 as 5 to the third power. So again, 5 to the third power means we're multiplying 5 by itself, 5 times 5 times 5, 3 times, 3 fives. So I want you to take a minute and pause this video, see if you can fill in the rest of the table, and then unpause it and see if you are correct. Let's look at the next row. We have 2 times itself, and we have 1, 2, 3, 4, 5 2's. Therefore, if we want to write this using exponents, we would write it as 2 to the 5th power. Notice the next 2 rows contain negative signs. In order to correctly express the idea of negative 3 times negative 3, we have to use parentheses. So the way we read this is we read it as negative 3 quantity squared. Notice that negative 3 times negative 3 is going to give us positive 9. Likewise, negative 3 quantity squared, in other words, negative 3 with parentheses around it, squared, is also equal to positive 9. And we'll spend more time in this video talking about signs and exponents, so please don't worry if you need more time to absorb this information. Okay, now we have negative 2 times itself, and we have 1, 2, 3, 4 of these. So again, we need to use parentheses. We're going to write parentheses, negative 2, close parentheses, to the 4th power. And again, the 4 comes from the fact that we have 4 negative 2's. Okay, so remember, when we have an even number of negative signs, they become positive. You can see this by knowing that negative 2 times negative 2 is positive 4. Negative 2 times negative 2 is positive 4, and 4 times 4 is positive 16. Therefore, negative 2 quantity to the 4th power is going to be positive 16. So here is a general guide of some of the vocabulary we're going to be using when we have exponents. So this bottom number here is called the base. So let's go back to our previous slide and identify the bases in the previous examples. So what is the base in this problem right here? 5 times 5 times 5. Well, the base here would be 5. So then we have this top number, which we write as a superscript, and that is called our exponent. So in our first example, 5 times 5 times 5, 5 is the base and 3 is the exponent. Let's take a minute and identify the base and the exponent in the other examples. Again, I encourage you to pause this video, do this on your own, and then unpause it to check yourself. In the second example, 2 is our base. In the third example, negative 3 is our base. And in the last example, negative 2 is our base. Notice that the parentheses mean that that negative sign is included in the base. The exponents are 5 in the second example, 2 in the third example, and 4 in the last example. So those are 2 words that you need to know. So again, the base is the bottom number, the large number, and the exponent is the number up top written as a superscript. And as you can see here, we have a basic definition of these 2 words. So again, the base is the number being multiplied. So if we go back to this example, right, where we rewrote these things as multiplication, 5 is the number being multiplied, 5 times 5 times 5. Then you can see the exponent is the number of times the base is used. So again, we can see that there are 1, 2, 3 5's here in this expression. Therefore, my exponent is 3. Let's look at the 0 power property. So by definition, any number except 0 raised to the 0 power is 1. So let's just do some basic examples here. What does this mean? Well, that means that 6 to the 0 power is 1. That means 100 to the 0 power is 1. That means negative 2 to the 0 power is 1. Again, the only exception to this rule is if I have 0 to the 0 power. Sometimes some sources will say that it's undefined. Some will define 0 to the 0 power as 1. I've seen that. But again, in this course, we're going to just say that 0 to the 0 power is undefined. Okay. But again, any other number besides 0, anything else, whether it's negative or positive, raised to the 0 power is defined as 1. So I want to encourage you to, again, pause this video, work through these problems, then unpause the video to see if you were correct. So as I do these problems, I want to first rewrite them as multiplication. If you're doing this on a test or quiz, you don't necessarily have to do this. Remember, you can always type 3 to the 4th power into your calculator and evaluate it directly. However, the purpose of this video is to help establish meaning behind the exponents so we get comfortable remembering what exponents mean and what they're doing. So 3 to the 4th power, remember that base is 3. 4 tells us that we're going to write 3 4 times. So 3 to the 4th power is equal to 3 times 3 times 3 times 3. So again, you can either type 3 to the 4th power into your calculator, or you can type in 3 times 3 times 3 times 3. Either way, the final answer is 81. So let's keep going. 2 to the 3rd power. The base is 2. The exponent is 3. That tells me that I have to write 2 3 times. So 2 times 2 times 2 is 8. Again, you could directly type in 2 to the 3rd power into a calculator and find out that it is 8. How about 10 to the 4th power? Well, we have 10 times 10 times 10 times 10. Okay, so that is going to give us 10,000. 45 to the 1st power. Well, we only write 45 once, so our final answer is just 45. How about 1 to the 4th power? Well, we can write it out as multiplication, but 1 times itself any number of times is still just 1. How about 6 to the 1st power? Well, we write 6 one time, so the answer is 6. How about 5 to the 0 power? Well, let's go back to our zero power property. The 0 power property says any number except for 0 itself raised to the 0 power is 1. Therefore, by definition, 5 to the 0 power is 1. This is something that you just really need to memorize, or again, get comfortable typing these into your calculator. If you type in 5 to the 0 power into your calculator, it should give you 1. How about 0 to the 4th power? Well, that's 0 times itself 4 times, but 0 times anything is just 0. So of course the answer is 0. So notice the difference between 0 to the 4th power and 4 to the 0 power. They have the same numbers in them, but they're not arranged in the same way. Therefore, we're not going to get the same answer for these two problems. So 4 to the 0 power is basically the same as 5 to the 0 power. Again, remember this 0 power property. Anything raised to the 0 power, except for 0 itself, is 1. Therefore, just as 5 to the 0 power is 1, so 4 to the 0 power is also 1. So that's our final answer. So most students, in my experience, do very well with exponents until we start introducing negative numbers. And I think the thing is that it's not that students don't understand how negative numbers work. I think it's the notation. So to be patient with yourself, think of this as learning a new language. If you know more than one language, you might know that in English, for example, I might say, I went to the store, right? And the subject comes first. And in other languages, they put those pieces of information in a different order. So again, math is about realizing, okay, what are they trying to communicate with these symbols? So that's what we need to learn here. We're really not learning arithmetic, we're learning a new language. So let's be patient with ourselves as we learn what these symbols mean. Okay, so there are two cases here, right? There are if we have no parentheses and if there are parentheses. Okay, so those are two ways of communicating something and they don't mean the same thing. Okay, so if there are no parentheses, so we're over here, we have negative 4 to the 2nd power. Now, many students get confused. They think that negative 4 to the 2nd power means negative 4 times negative 4. That's what they think. Okay, and that makes sense to me. However, that is not what we mean when we say negative 4 to the 2nd power. Okay, so this exponent is only going to act on whatever it's right next to unless there are parentheses. Okay, there are no parentheses, therefore the base is just positive 4. So the way we're going to think about this is that there is only one negative sign. Okay, the negative sign, because it's outside of, right, it's not right next to the squared, is not getting duplicated. So we're just going to leave him alone. So then we just have the 4. The 4 is what's getting multiplied by itself twice, not the negative. So we have negative 4 times 4. Again, there's no parentheses. The negative sign is not getting duplicated. So we have negative 16. Okay, let's do it for the next problem. So this time, again, we have one negative sign. Notice there is a space between the negative sign and the exponent, and there are no parentheses. So when I teach this in class, I kind of make a joke. The negative sign was not invited to the party. There's only one negative sign. He's not getting duplicated. What is getting duplicated, right, is just the base. The base is just the positive 2. So the negative sign, again, is just going to hang out there. And then our exponent, right, 2 to the 3rd power, right? Another way to think about it is with the negative sign on the outside and then 2 to the 3rd power on the inside. Okay, again, there's only one negative sign. It's not getting replicated. So 2 times 2 times 2 is 8. And again, there's that one negative, so the one negative sign carries over. All right, let's do one more. So now we have negative 2 to the 4th power. Again, what is getting raised to the 4th power? Only 2. The negative sign was not invited to the party. The negative sign stays there. There's only one of them. It is not getting replicated. Okay, the thing that's getting replicated is just 2. 2 times itself 4 times is 16. So my final answer is negative 16. Okay, so if we stand back and look at these examples, we can see that all of these are negative. It doesn't even matter if we have an even exponent or if we have an odd exponent. It doesn't matter, right? Because there's only one negative sign. So in the absence of parentheses, right, and then we have a negative sign outside of our base and our exponent, then we're going to end up with a negative number. Okay, so again, notation, we're learning a new language here. We're really not learning about the math. We're learning about language and communication, right? What we're trying to communicate here is that only the 4, only the base, the 4 or the 2 or the 2 is getting replicated. The negative sign is not getting replicated when we write it like that. Okay, so let's look at this other column. What if there are parentheses? Okay, so in this case, right, what's getting invited to the party? What's getting squared? Well, negative 4, right? The whole thing is enveloped in a set of parentheses. So we're going to have negative 4 times negative 4, and that's going to give me positive 16. Again, the parentheses are indicating now that this whole thing, not just the 4, but the negative 4, is what's getting duplicated. Likewise, if I have negative 2 quantity to the 3rd power, that's how we read it mathematically, then the base is negative 2. What's getting replicated is not just 2, but negative 2. And the exponent of 3 tells me that I write it 3 times. So what is negative 2 times negative 2 times negative 2? Well, negative times a negative is a positive, and then 4 times negative 2 is negative 8. Again, I want to invite you to remember your calculator. Even if you just have a basic scientific calculator, you don't have to spend a lot of money on it, we'll do this. It should have parentheses. So you should be able to type directly into a calculator, parentheses, negative 2, parentheses, to the 3rd power. Okay, you can ask your instructor or you can go online and try to find videos that teach you how to do that with your specific type of calculator. All right, let's do the last problem. Again, these parentheses tell us that negative 2, that negative sign was invited to the party. The base is not 2 anymore, it's negative 2. Okay, and we're duplicating negative 2. We're going to write it 4 times. That's what that exponent tells us. So that is going to give us a positive 16. Another pattern to notice, if you like to pay attention to patterns, is that if I take a negative number and raise it to an even power, notice in both of these cases it becomes positive. If I raise a negative number to an odd power, then it's going to stay negative. And this goes back to if you watch the video on signed multiplication. Remember, if we have an odd number of negative signs, whether we're multiplying or dividing, it doesn't matter, that's going to give us a negative number. And if we have an even number of negative signs being multiplied by each other, then it ends up being positive. So again, I want to encourage you to take a minute, pause this video, work through these 6 examples, and then unpause it and check yourself. So negative 3 to the second power. Is this negative sign getting duplicated? Is that what's meant by this notation? Well, we can go back here and check, right? And the answer is no, right? There are no parentheses, so we only write that negative sign once. So we have negative 3 times 3, which is negative 9. Okay, how about negative 3 quantity squared? What's getting duplicated? Well, we're going to write negative 3 twice. So I have negative 3 times negative 3, so that's positive 3. Again, I'm going to bring your attention to the fact that these 2 expressions do not mean the same thing, right? They're going to give you different answers. So remember that. Again, we're not really learning math here, we're learning communication. We're learning different symbols. If you've ever learned to play an instrument, you probably had to learn to read music, right? So that's a different way of communicating. That's all we're doing. We're learning a different set of symbols and what they mean. So I want to jump down to the bottom row here. So I have negative 3 to the third power. So what's getting raised to the third power? Well, it's just 3. Remember that negative sign is not getting duplicated. So the negative sign only gets written once as a multiplication problem. So you have negative 3 times 3 times 3. That is going to give you negative 27. Okay, and then this next problem, remember the negative is getting duplicated, right? So I write negative 3 times. And it turns out that in both cases, because we have an odd exponent, in both cases, we still get negative 27. However, the way we got negative 27, meaning this work right here, is fundamentally different. All right, so let's look at these last 2 examples. I saved those for last because they're different. They're a little bit new from anything we've done, okay? So the way I'm going to do this is I'm going to break it down into 2 pieces. First, I'm going to just ignore this negative sign, pretend it's not there, and just evaluate negative 3 quantity squared. So you might realize, hey, negative 3 quantity squared, we already did that, didn't we? We already did negative 3 times negative 3, and we already know that that is going to give me a positive 9. So now, let's go back to our original problem, and let's bring down that negative sign. And for clarity purposes, I'm going to put this in parentheses, and then I'm going to bring this negative sign down here. And then I'm going to bring it down one more time, like that. And so now you can see our final answer is negative 9. So it's okay to break these up into pieces and to go slowly until you get the right answer. Let's do this last problem. So now we have negative parentheses, negative 3 to the third power. Again, remember, right, we've already done this problem, haven't we? We already know that negative 3 quantity to the third power is negative 3 times negative 3 times negative 3, and we know that that is negative 27. So now let's go back and put this in parentheses and just carry down that negative sign. Okay, so what is negative 27? Well, another way to think about this, and you don't have to do this if you want, is really it's negative 1 times negative 27. So remember, when you change signs, it's like a light switch. So if I have a light that's on, I turn it off, and then I turn it back on again, it's back to its original state. So remember, minus a negative is the same as plus a positive. Therefore, minus negative 27 is the same as positive 27. So that would be our final answer.